Good morning, everyone. Before we begin our presentation, let me introduce my group member, Salina, Gavi, Azam, and myself, Razin. Together, we will be presenting on the topic How Google Maps using Discrete Mathematics. We hope you enjoy our presentation. Have you ever wondered how apps like Google Maps always seem to know the fastest route, help you avoid traffic, and even point you to the nearest cafe? It is not just GPS. It is actually powered by something called Discrete Mathematics. Behind the scene, Google Maps represent routes and intersections as graphs and use algorithms like Dijkstra and A to find the shortest path between 2 points. Discrete math also help compare routes, handle constraints like traffic jam or road closure, and make smart decisions instantly. But as cities like Kuala Lumpur, Penang, and Johor Bahru grow more crowded, traffic gets more unpredictable. That is why modern navigation systems now combine math with technology like AI, big data, IoT, and edge computing. These tools analyze your habit, live traffic, and even local events to give you more personalized and responsive routes.
I'll be explaining how discrete mathematics is applied in modern navigation systems like Google Maps, focusing on a few key areas. First, we have graph theory. In navigation systems, maps are modeled as graphs. Intersections or locations are represented as nodes, and the routes connecting them are edges. Each edges can have a weight, such as distance or estimated travel time. By modeling maps this way, systems like Google Maps can analyze the road network mathematically and efficiently. Next is shortest path algorithms. Algorithms like JIT10503 are used to find the shortest or fastest path between 2 points. However, for real-time and more dynamic routing, an advanced algorithm called A* is often used. It adds a heuristic function to better estimate the most efficient path, especially in large-scale networks. Third, combinatorics. Combinatorics comes into play when analyzing multiple route options. For example, users may want to avoid tolls, highways, or traffic. Combinatorics helps evaluate and compare various route combinations to offer the best fit based on user preferences. Matrices and discrete structures. To store and process map data, systems use structures like adjacency matrices and adjacency lists. These help in efficiently handling real-time updates such as traffic conditions or road closures. Next, logic and set theory. Logic is used for decision making, such as rerouting due to a road closure. Set theory helps in filtering or grouping road segments. For instance, users might filter routes to avoid highways. Set operations help implement those preferences. Discrete optimization. Lastly, discrete optimization ensures that suggested routes are not just short, but also efficient in terms of time, fuel, and traffic. By balancing all constraints, the system can generate the most optimal route for each user. So overall, discrete mathematics provide the foundation for how navigation systems think, analyze, and adapt in real time.
Next is problems without discrete mathematics. First is inability to model real-world road networks efficiently. Road networks are naturally discrete systems made up of intersections and roads. Without discrete mathematics, we wouldn't have a structured way to represent them. Everything would be unorganized, making it very hard to analyze or find routes. Discrete math helps to structure the data logically using nodes and edges. Second will be longer road calculation time. Road calculation would take much longer time without efficient algorithms such as Discrete or A*. Without them, the system would use brute force method, checking all the possible routes from the start to the destination. This is very slow, especially in big cities with thousands of roads. So real-time navigation would become too slow to be useful. Continuing with suboptimal or incorrect routes. Without a proper optimization algorithm, user might get longer or slower routes instead of the faster path. This wasted time, fuel, and cause frustration. Important details like avoiding tolls, traffic, roadblocks might also be ignored, which makes the system less reliable. Continuing with fail to adapt the traffic condition. Discrete mathematics also support logical filtering. This lets the system avoid one-way streets, roads under maintenance, or those with time-based restriction. Without this logic, user could be guided into illegal or blocked roads, which could lead to confusion, delay, and even accident. Last but not least, inability to scale with larger maps. Without graph-based structures and efficient algorithms, Google Maps wouldn't be able to handle large-scale maps. It processes entire countries' road networks. Without discrete maps, memory and processing would become overloaded, making the system crash or respond too slow.
Traffic jam always happens quickly in KL, Penang, and Johor Bahru. During festival season like Hari Raya, it gets worse. People spend hours stuck in traffic, feel frustrated. We already have apps like Google Maps and Waze. They help, but honestly, they can still be improved. They just show a road based on a traffic right just now, but they don't understand how local traffic pattern. By utilizing AI and big data, the system can learn from the past traffic data, which or it can predict which balik kampung traffic will be happen, which will always them, and avoid toll road, and then suggest better route for based on that. With IoT and edge computing, smart traffic light and road sensor can detect accident or sudden traffic jams immediately. They can just make fast decision directly without waiting for cloud server. So road like Jalan Pengaza or Opinion page, the traffic light can just automatically based on how heavy the traffic is. Further learning app protect user privacy. Personal data stays safely on this device because Malaysia has personal data protection act. By combine all these technologies, the patient app won't just give a direction, but actually help manage traffic better, reduce waiting time, and free lifestyle for everyone.
To summarize, discrete mathematics plays a vital role in making navigation systems like Google Maps work. Using graph theory and algorithm, it helps plan routes, avoid traffic, and make quick decisions in real time. Without it, the system would be slower, less accurate, and unable to adapt to changing road conditions. To make them even better, technology like big data, IoT, and edge computing are now being used. These tools allow apps to analyze live traffic, user behavior, and local events to give smarter, more personalized directions. In traffic-heavy cities like Kuala Lumpur, Penang, and Johor Bahru, this combination of math and technology can help reduce congestion and improve road safety. In short, discrete mathematics together with modern technology is the key to bring faster, smarter, and safer navigation system for the future. Thank you.